Hello students, welcome to the video lecture 5 of the chapter Magnetism and Matter. Today's content to be discussed are Earth's magnetism and elements of Earth's magnetism. So let us begin with today's content. Earth's magnetism. The Earth's magnetic field arises due to the electrical current produced by the motion of metallic fluids, that is molten iron and nickel inside the outer core of Earth. This we call it to be the dynamo effect. So here let us try to have a look at the inner and outer cores. So in the outer core we see that there is a circulating electric current which causes the magnetic field of Earth. This magnetic field of Earth has a strength of order of 10 to the power minus 5 Tesla. Assuming the Earth here, we know that Earth has a geographic axis about which it rotates. So at the top we have shown NG. NG is geographic North Pole and SG is geographic South Pole. Corresponding to that, we can draw an equator that will be called as geographic equator. Slightly tilted to this, we have one more equator. We call it to be magnetic equator. Then for this magnetic equator, we can draw an axis. That axis is 11.3 degree tilted with respect to the axis of rotation of Earth, which you can see here. So which is 11.3 degree tilted with respect to the axis of rotation. The magnetic pole which is near to the geographic north, we call it to be magnetic north pole, NM, and the pole which is close to geographic south, we call it to be magnetic south pole. And here the magnetic field of Earth is not similar to that of bar magnet. In case of Earth's magnetic field, the field lines go into the Earth's north pole and come out from the Earth's magnetic south pole, which is opposite to that in case of bar magnet. Moving ahead, the evidence of Earth's magnetism. First, we can identify that Earth has magnetic field just by suspending a magnetic needle. When we suspend it freely, then it comes in the alignment of north and south direction. This provides us evidence that Earth has magnetic field. And also, if we bury an iron piece into Earth after a long time, we see to it that the iron piece have got into a magnet. Next, now let us study elements of Earth's magnetic field. To describe Earth's magnetic field at a point on the surface of Earth, we need to specify three quantities. Those quantities are, firstly, declination d at a place, the angle of dip I or else inclination at that place, and horizontal component of Earth's magnetic field He. These three elements are known as elements of Earth's magnetic field. Let us define them one by one. Magnetic declination, capital D. The angle between the true geographic north and the north shown by the magnet is called declination. True geographic north means the geographic north. Let us try to take a magnetic compass since magnetic compass is going to show us the direction of magnetic north and south direction, and true geographic north will be the geographic axis direction. So the angle between these two at a given place will be called as declination. So it can also be defined as angle between the magnetic meridian and geographic meridian. So here question arises, what is magnetic meridian and geographic meridian? So let us define them. Geographic meridian is the plane passing through the given place and the geographic north and south pole of the earth. Such a plane will be called as geographic meridian. And magnetic meridian is a plane passing through the given place and also the magnetic north and south pole of the earth. Such a plane is called as magnetic meridian. Moving ahead, let us now define angle of dip or inclination. The angle between the total magnetic field of earth and the horizontal surface of earth. So we see the compass is showing the total magnetic field of earth, that is BE, and at that place whatever horizontal surface is there, with respect to that whatever BE makes the angle, that is called as I, that is inclination. So inclination is maximum, that is 90 degree at poles, and minimum 0 degree at the equators. Lastly, horizontal component of Earth's magnetic field He. Let us consider Earth here. Let this be the line showing the magnetic north pole at the top. Let us choose a point P on the surface of Earth, and the blue color line shows the horizontal component of Earth's magnetic field. Let us take this green colored line to be showing us the vertical component of Earth's magnetic field represented with Ze. So together they give us the total magnetic field of Earth at that place P, and we know the angle between HE and BE is I. I is angle of dip. Yes, moving ahead, using this diagram, let us try to find the magnitude of I. So from the diagram we can write ZE is equal to BE sin I. Since ZE and HE are the rectangular components of BE, we can write ZE equals to BE sin I. Similarly, we can write for HE, that will come out to be HE equals to BE cos I. Taking both the equations as 1 and 2. Now let us try to divide 1 and 2. Then we get ZE divided by HE equals tan I. To find magnitude of I, we can write the equation as I is equal to tan inverse ZE divided by HE. This gives us the value of inclination at a place. Moving ahead, now let us try to find out the magnitude of B at a place. Squaring and adding equation 1 and 2, we get ZE square plus HE square is equal to BE square sin square I plus cos square I. So we can write it to be root ZE square plus HE square equals BE, which gives us the value of total magnetic field at a place. Thank you students. See you in the next video lecture.